Hey everybody, welcome to the stream. In the last stream, my internet was not working properly, so we were not able to implement this project that we were working on in the last stream. So today we are going to implement the model for Fruit 360 model. I mean Fruit 360 dataset. Hopefully today we don't have to download the dataset and extract it because we already have it inside my Google Drive. So it won't take time today to download and extract it. It almost took I think more than 10 minutes to extract all the data from the zip file. Alright, so we had the data today now. So let's get started implementing the model. Let me get the path for the data set. It is inside test training. Okay, we don't need papers folder. We will be mostly working with the training data set, and it also contains the test data set. So for this data set we won't be able we won't need to use the splitter because we already have it splitted based on training and test set. So let me see how to get the data inside the data block. Do we have to get the base path? Let me set the base path as this path. Path is not defined. Okay, yeah, we have not defined the path. All right, we need to get the path to the data set. So if I select, let's see which path should we select. Let me select the path up to Fruit 360. Should copy the path and put it inside the path variable. Oops, it should be path. All right, so we have it inside the path variable now, and now we should select the base path as that path. And now if I try to ls, not that ls, to ls, whatever it inside the path, it should show us this folders. String object has no attribute, right? Why doesn't it have the attribute? Because I guess this path is not converted to this path, so we might have to do something like this. Now if I try to ls, we get this data. Good, so we have the data inside the path now. We can grab the training data set. We don't need to ls this images, and now we need to, well, this is how we get the file name. So let me try to get the file name as well. If I do path slash training and inside training, Well, inside training we have another folder. We don't need to check that. So let's get the data block now. We should call it fruits data block. Data block. For the data block, blocks will contain, well, the independent variable is an image, so we need to get the image block first, and the dependent variables are categories, so we can get the category block. All right, we have the category block as well. Now we need to get the items. Can we directly get the image files? So we're going to pass the path. Yes, we can. I think we have to create our own custom function to get the files. Let me check another notebook. We use the custom function in this notebook, I think, multi-category. So this when we get the data block and we call the data sets, it creates training and valid data set directly this data block TPA. Cool, but we don't want it to split the data into training and valid. This is get x, get items and get x. What's the difference between get x and get items? So we used get x in this case. Let me check the API of data block. I should refer to the FastAI docs, I guess. FastAI data block. Transform block. General API. Yes. Data block. We have get items and get x. Where there these two things. To build a data block, you need to give the library four things: the type of your input labels, and at least two function. At least two function, get items and splitter. You may also need to include get x and get y, or a more generic list of getters that are applied to the results of get item. Alright, so this get x is applied to these get items. What is it trying to say? Get image files. We didn't use get items in this data block. Why did we not use the get items? Because we were calling getX directly. Maybe. And getX included, well, it included the file names. Not only file names, it contained a path to the image. All right. And after we pass the blocks, it converted those file paths to images. And get y, this category is to 110 coded tensor. All right. And let me try to give the get images argument then. I should pass get image files. Now for the splitter is somewhat difficult because we can't use a random splitter, because we don't want to split the data. We already have it splitted inside training and test. Training and test. Wait, should we keep this training as it is? Because we can create the training and validation data from this training data as well, because apparently we have so much of data inside training. Check how much it contains. 131 directories, and those directories contains almost like 500 files or 500 images per category. So that's a lot of data. I think we can split this training date only. I think we can split the training data set for validation and training. So in that case, we can use a random split. In this multi-category, we used let me see, we used a custom splitter because we already had this variable is valid. In this case, we can use a random splitter. Let's just use the random splitter. Random splitter give seed of 42. All right. Get y. Now we need to get the what can we say? It is independent variable, dependent variable. Now we have used a custom function to get the parent. In this case, we can directly use, let me check this parent label, because those images are inside folders which are already named after the images that are contained within that folder. So we can get the parent label. All right. After we have got the parent label, we can apply the transform. Can apply the same transform, resize, and this is resizing, I guess. Let's just apply this transform and we will see if we can do something to it later. All right, we have the data blocking. Now let's check if we have correct data. inside this data block or not. So we can do VLS data loaders. First we are checking the data set. Alright, let's check the data set first. So for that we need to get the fruits. We're going to check the data set first. So let's get fruits and data sets. We want the data set from this path. So we can pass path slash training. It is capital T and ING training. Let's check the data sets now. It contains almost 6,698 items. Okay, select train. Then the training data set contains 5,359. And we also had valid. 1,500 for the valid. Let's check the train and first contains an image of, wait, this category is empty. That means we are not getting the correct dependent variable. Let me check what is inside this function. Get parent label path O. Whatever path we pass, like whatever item is passed to this, we need to get the parent name. Alright, we are not getting the parent name. Let me check let's check all the data first. Wait, I think it is correct. We have this categories. Alright, let's check the vocab. The vocab will contain the labels. So the vocab will show us all the labels. And we can get the vocab using okay. We can get the vocab. It's inside ELS vocab. Let me check if it is inside datasets or not. Okay, it is inside the datasets. And if I check the shape of this vocab, category map doesn't have shape. Cool, then you can get the length then 14. All right, so it is saying we have 14 categories, but inside this training we have 131 directories. How is that possible? Let me check the vocabs again. Did I type? Okay, not fake op. Okay. It contains apple, crimson, apple golden. So if I check it correctly, it contains up to apricot. And after that, we don't have anything. Why is that the case? We have up to apricot only. Apparently, we should have 131 vocabs. We are only getting 14. Why is that the case? Does it mean we are not getting all the images? By the way, why is this image 100 by 100 size? Should be 224 by 224. X is a function provided by FastAI that simply gets the name of the folder a file is in. Because we put each of our bare images into folder based on type of file, this is going to give us labels that we need. Okay. Get image file. Okay, what does this function does? It takes a path and returns a list of all images in that path recursively by default. Okay, so if I pass path dot dash training, now that path contains folders. Those folder contains the images, right? Yeah, those folder contains the images. So it seems correct. All right, so this get image files get all the files recursively. So it seems to be working correctly, but apparently we are not getting all the labels inside the vocab. Now, why is that the case? Maybe if we are doing random splitting, we are not getting all, well, maybe we are not getting all the labels. Is that the case? Now this vocab shows us that this vocab should contain all the labels, right? Can we check the summary? Okay, we have to pass path training. So this is what the data block API is doing. First, it gets all the 6,698 items. All right, so it found this many images. After that, it is segregating it into two data sets. One of two, one this is for the training data set, and this is for the validation. Now it is getting the labels. It is getting the labels. Now it starts collecting the image, starting from this folder, right? There's the first image, and it applies the transform to the image, and it gets the vocab. So the parent label does give this label apple ripen. Now it is giving us the label, but Tensor category. Okay, wait. We have 0, 1, 4 and 10 inside tensor category. Why is that the case? Why do we just have 4 categories? The summary contains 4 categories. The vocab contains almost 14 categories, but in actuality we have 131 categories. Wait, is it because of the random splitter? What's the default value of the random splitter? Valid percentage is equal to 0.2. Let's check the splitters API. Splitters, it should be inside data only. Blocks, core contains filter based data sets. The splitters, maybe it is inside data loader. Right, no, it isn't inside data loader. What about external? Not inside external as well. And transform, I don't think it is inside transform as well. Or maybe it is, yeah, it is inside transform. It is inside split. Okay, the next set of function are used to split data into training and validation. Alright, I think we need to use this splitter, which splits item into stratified fashion uniformly according to the labels distribution. Train test splitter. Random state none. Stratify none. Let's use this function and we should pass it over here. And the test set should be 0.2. Labels is not defined. Wait, what was inside labels? They are giving 0 into 1 into 10. What are they passing to the labels? 20 into 10. What is this? Let me check what kind of data is being passed. Okay, we can also pass this grandparent splitter because we do have a training and test folder. This will definitely increase the dataset size, but alright, let's try to use the grandparent splitter. See if it takes time or not. So if I pass it over here, and the path for the training data set is inside training folder, and the validation, it is not validation, but this is the test data set. Let's not use the grandparent. Let's use the train test splitter only. Change it back. Okay, we have test train splitter. Now we need to check what we should pass to the stratify. We should pass something to the stratify. Test and wait, are they using the scikit-learn test train splitter? Use scikit-learn test train test split. This allows item to. Okay, let me check the scikit-learn train test split. So they are using this function internally. Stratify is equal to none. Let me check what do we have to pass to the stratify. Array like default is equal to, if none, data split in the stratified fashion using this as the class labels. What do you mean this as the class label? X, Y, it has a random state. This is X train, Y train. We are passing in this X and this one. If not none, data is split in a stratified fashion using this as the class labels. So they are passing an array containing 20 zeros and 10 ones. 20 0 and 10 ones. They're passing it as the labels. Okay. What is source contains? Source contains a list of 0 to 29 integers. Should I pass parent label over here? Let me pass the parent label over here and see if it works or not. It is saying that Okay, we have to pass. This is correct. It can't be considered as a valid collection. We can't pass parent label. What do we have to pass then? Because we need a stratified splitter. Let me check some more examples of stratified splitter. It is from a skill. Let's check the Stack Overflow and to split my data into training and test. He's passing user info. Certify your column label. I have also prepared a short GitHub gist which shows how to have static. Okay, that's what we want. How does it work? What is he doing? Experiment to confirm the effect of stratify option. He is passing X your column, right? And we don't already have this column, right? Our column labels are inside the parent label. Can we use let me Google FastAI. What is it? Stratified test and splitter. Spotify option. And let me check the vocab now. It still contains 14. Apparently, it is not retrieving all the images from all the categories. But even if it is not getting the images, all the images from each category into training, it must contain it inside the test set, right? And if it is inside test set, it should give the correct label, because it is creating the same data block for the test set as well. So it should contain the correct label, or I should say all the labels. Okay, let me check the batch. DLS, of course we are not getting the data out of this. Well, alright, let me try to get the data out of this then. Stop data loaders and we only have the apples inside validation set. Let me check 4 rows. Versus 16. It doesn't contain other fruits and vegetables. It contains apple, all of them are apples. There's something wrong with the data block API, I guess. By the way, I will be back in 2 minutes, guys. Stay tuned. have images inside other folders or not? Which are cauliflower. Wait, is it empty or what? Let me check. Path slash training slash, let's say, con. P is not. Okay, that's the case. We don't have data inside other folders. Oh hell, that means the images were not extracted properly. Well, if that's the case, we might have to download. Wait, but it got extracted properly yesterday. Didn't we get all the data? And also it contains up to Huckleberry only. If I check this Kaggle, there's other folders as well. So that means we didn't get all the data. So that was causing the problem. Maybe the storage space of Google Drive ran out. Let me check. Well, no, it is empty. I mean, I have enough space to get all the data. I'm checking other Google Drive. There is enough space for all the data. Okay, so that means we have to get the data again and extract it. Cool. So I think we have to get the data again. Alright, we will get it again. Can't do anything else. Let me quickly get the data and I will get back to you guys. I have downloaded the data. Now we need to unzip it. Okay, so it is unzipping the data now, and like before, it is going to take time. I hope the space doesn't run out. I hope you guys can hear me. I'm testing the music feature of Twitch stream. Oh, right. It is starting with the training dataset now, and it isn't even halfway through. Oh, hold on, guys. It's going to take some more time. Kaki. I have heard this name for the first time. Kaki, is that a fruit or a vegetable? Check. Kaki. It looks like a fruit. So it is down to lemon right now. Lemon. We have 71 more to go. It's down to lemon and lychee. YouTube is telling me that the connection is poor. That it seems alright on Twitch. Well, it seems alright to me. Oh damn, how much longer it is going to take? Pierre Forel. Pierre Forel. It's up to this one right now. We have almost 35 more to go. Well, I think I know why we didn't have the complete data set. Because after extracting this, our stream got disconnected yesterday. So that's why all the remaining data was not saved to the Google Drive. So yeah, that's the case. So this time I'm going to manually click on the save button after this is done extracting. I don't want to extract the data all over again. Let's hope that the internet stays healthy today. If it doesn't and if we lose the data again, then I'm going to extract the data off stream today so that we don't have to wait it on stream. We are over here to red current select. So we still have 11, almost 14, 15 categories more to extract. I hope there's no other folder to extract. We have already extracted the test folder and the training folder is going on right now. Let me check how much data is inside test multiple fruits. Well, these are just 73 or 80 or 90 images. So it won't take much time for this folder, and this folder papers contains only one PDF, so it will be quick for these two folders. We have more than 90,000 JPEG files, so there's a hell lot of data. We definitely don't need all of those data, and most of them are almost similar. If we check this, you can see that most of them are almost similar. If we try to train it on try to train our model on all the data, it's going to take a hell lot of time, or maybe it will crash the Google Colab. So I'd have to find out technique to select only subset of data. Maybe we have that kind of splitter. I saw it somewhere over here. Random subset splitter. Take random subsets of split with train as the okay. So we do have a random subset, so we are going to use this folder. It takes training data size and validation size. Because if we use all the data, it is going to crash our Google Colab for sure. Wait, what happened? Stop extracting. It extracted up to tomatoes. Why? Why did it stop? What the hell? It didn't give us all the data. Let me check the Google Drive. It contains watermelon, but it seems there are no images inside. Oh yeah, yeah. It does contain all the images. So maybe it was not doing it sequentially. Let me check the test multiple fruits as well. It does contains everything. But let me check if we have any function which can give the number of all the image files. I think there was one inside this notebook. It was get images or something. Yeah, it was verify images. Alright, we can get images using this function. So let's check it out. Function get image files, and the path is /training. It contains 67,692 image files. And saying that this it contains 90,000. Okay, yeah, we are only getting the training folder. Let me pass the whole folder and see. Yeah, we are getting 90,000, 90.5k. So this time we have got all the data. Let me save it again. Cool. So now that we have got all the data, let's try to create the data block. And this time we are going to use subset splitter. Let me check in which notebook it was mentioned the use cases of different subset splitters. Inside this, I guess. It wasn't inside this. What about this? Maybe here. Was it inside the intro folder? I want to check where the author talked about a random subset splitter, because he did talk about the random subset splitter, and I want to check how he used it. There's no mention of splitter in this notebook. Sizing, NLP convolutions. Well, it's alright, it doesn't matter. We're going to use the random subset splitter anyway. So we are using it like this. We're passing 0.3% and 0.1% as the validation. Let me try to use that splitter and see how much data we are getting. Let's check the vocab now. Alright, we're getting all the 131 categories. Cool. So this time we are getting all the categories. So, and we have almost 0.3% data set. So let's check how much data set is inside train. We have 20,000 inside the training data set and 6,769 inside the validation. So that will be enough, I guess. And it contains images of site 100 by 100. Let me check the validation batch. Cool. So this time we are getting all the data and the size seems correct. And let me quickly check the summary as well. Apparently it is converting to 100 by 100 size, but I don't think why that should be the case, because we are passing, wait, those images 100 by 100 by default in this data set? Yeah, they are, all of them are already resized to 100 by 100. Let me check if they have mentioned it somewhere. File format, image indexing pointer. Alright, so it seems they have already transformed the images. Does that mean we don't need to use a resize option? Let me try to remove this option and see if it gives us any error. If I remove the resize option, and we can keep the augmentation transform, right? What's the default size? There's none if I don't provide any size. Let me remove the size as well. Okay, it is not giving us any errors. Let's quickly check the vocab size as well. It should not be changed. And let's check the summary. It will contain the information that we need. So if we check over here, it is transforming. So it is transforming. Let's check the training data set to see if, okay, it is augmenting and it is apparently cropping the data set. Let me check the augmentation using unique is equal to true. We don't want 18 of those. Let's get 8 inside 2 rows, and unique is equal to true. Now it will give us the same images but augmented. So this kind of augmentation is applied. All right, it's all right. Let's try to get the model now. Save it again, although it is being auto saved. Now let's get the learner. We need the CNN learner. Pass it the data loader and give ResNet 34 as the architecture. The metrics, let's just keep it as error rate. And let's use the default fine tune, then we will use the other techniques. I think we need to reduce the subset size uh, further, because apparently it is taking a lot of time. It is done with one epoch, and okay, our model is done fine tuning and we got down to 0.76. So that's not a good error rate. We are going to fine tune it again, but first of all, this is a hell lot of data to train the model. We need to further reduce the data set. We are passing 0.3%. This is 0.30%, right? I guess we're getting almost 20,000 of, yeah, it is, I guess, let me check, we have in total 90,000. We have 90,000 and we are getting 0.3%. It is not 0.3, it is 0.30. 30% data. We don't need that much. What if I pass 0.2, let's say, and get 0.05 for the validation? Now let's check the data set size for training. Dsets dot valid. Oops, I need to pass comma. Now we have 13,000 images inside the training set and 3,000 inside the validation. It is still a lot of images, and let's check the vocab as well to see if we have, yeah, we have all the categories. Can I just check the vocab of training? Right, so the training vocab contains all the categories as well. So let me reduce it further, something like, skip it at 0.1 only, and this should be 0.3. And if I check the data sets, now we have 6,000 and 2,000. Well, it's all right. Now let's see how much time it takes. Well, in this time it didn't take that much time to complete the first epoch. So this was for the random weights, and this is for all the layers. So when we were training for this epoch, all the other pre-trained layers were frozen. So we are now down to 0.76, and this much time is manageable, I guess, for tuning the hyperparameters. Now let's see what are the things we can do. We are doing the augmentation transform. Let's check the dataset. Do we need to augment it? Well, it's all right if we augment it. It's okay. Now let's try to use well, I think I'm gonna take a break now. I have to get my lunch now. So we will fine tune it later in the next stream, I guess. Alright guys, then I'm signing off now. I will see you guys in the next stream. Bye.